And we're back and better than ever in 18-5 where we're dealing with rate laws. In the first podcast of this section, we introduced you to the idea of rate laws and the fact that because the rate of reaction changes, we cannot express it with a simple equation, or with a simple number. We have to use an equation. And so we showed you how we could write the general form of the rate law. Let me scroll back on up. You write the general form of the rate law using the reactants, the rate constant, and the reaction orders. You observe tables where you change the concentration of the reactants and observe the rates. And then you can determine the orders of reaction and the rate constants by simply plugging in and solving. And so let's go ahead and work our way through reaction number 2, where you have nitrite, which is right here, reacting with the ammonium ion right there to form nitrogen and water. And here's the data that we're collecting. So again, we'll write the general form of the rate law. You just have to say rate equals K times the first reactant raised to some unknown power, we'll use M, times the second reactant raised to some unknown power, we'll say N, and that's it. You only use the reactants, not the products, because the products are barely formed at this point and there's no reverse reaction, so you don't need to worry about that. So there's the general form of the rate law. Now you need to determine the reaction orders. Well, again, all you need to do is watch how the concentrations change and then watch how the rates change with it. And so if we take a look at reaction number 1 and 2, notice that the nitrite doubles, but nothing happens to the ammonium. So we know that the only effect on the rate is due to the nitrite. So in this case, the nitrite doubles, so we'll say times 2. Now observe the rate. Well, it goes from 5.4 to 10.8 times 10 to the negative 7. So the rate also doubles. When the concentration doubles and the rate doubles, then it is a first order. So just recording it down here, if we take a look at 1 and 2, nitrite doubles, rate doubles, so therefore it is a first order with respect to the nitrate. So I'm just going to say that equals 1. We'll write that out in just a second. Now we need to take a look at the ammonium. In order to figure out the ammonium, we're going to have to observe number 3 and number 4. Because in number 3 and number 4, the nitrite stays the same, so we don't have to worry about that. But here's where the ammonium doubles. So this is times 2. Now let's compare the rates between those two experiments. You go from 10.8 times 10 to the negative 7 up to 21.6. So that also doubles. So therefore, comparing 3 and 4, the ammonium doubles, the rate doubles, and so therefore it is a first order with respect to the ammonium as well, so we'll make that equal to 1 up here. So therefore we can write this out as rate equals K times nitrite concentration raised to the first power, of course we just leave it off, times the ammonium raised to the first power, which you can just leave blank. And so now we have a better idea what this rate law is. The only thing we need to solve for now is the rate constant K. And so to solve for the rate constant K, you simply pick one of the equations. And so let's just go ahead and pick, let's go with this first one, number 1, because I have a 0.01 in there. It just looks like it'd be a little bit easier to work with. So we'll go ahead and scroll down. And so we're going to say that the rate in that experiment number 1 is 5.4 times 10 to the negative 7. That's going to equal K times the nitrite, which is 0.0100, times the ammonium, which is 0.200. And if you divide both sides by 0.0100, and by 0.200, these terms will divide out. You're left only with k, and now k is going to equal 5.4 times 10 to the negative 7 divided by this entire denominator, which is actually going to be 2.7 times 10 to the negative 4. So that would be the rate constant for this particular reaction at this temperature. So now overall, we can say that rate equals 2.7 times 10 to the negative 4 times the nitrite times the ammonium. All right? Okay. Let's go ahead and move on then to the next page, where we're going to deal with yet another another reaction where we want to determine the rate law. So, here's the equation. You have bromate plus bromide plus hydrogen. Let's go ahead and change those colors just so we can follow along. We'll make this one blue. We'll talk about this one in terms of red, and we'll talk about this last one in terms of green. Alright, so we need to figure out what the rate law is first. Well, you're always going to say that rate is going to equal some rate constant K times the bromate raised to some unknown power, M, the reaction order, times the bromide raised to some unknown power, times the hydrogen raised to some unknown power. We're actually going to use a P instead of an O, because that O could be a 0. We don't want any confusion. So we'll use M, N, and P as our exponents there. So that's the general form of the rate law. Now we need to figure out what the reaction orders are. Alright, so let's do some comparison. Let's take a look. We'll use our blue here. Let's compare two reactions where only the bromate changes. Well, if you look at reaction 1 and 2, or experiment 1 and 2, the bromate doubles, but yet these two stay the same, so we're good there. These two stay the same, so we're good there. So now we're only looking at the bromate. The bromate doubles times 2. The rate goes from 8 to 16 times 10 to the negative third, so that also doubles. So therefore, we know that this is going to be a first order with respect to the bromate. Let's take a look at the bromide. Well, in this case, let's look at experiment, say, 2 and 3. Because here, the bromide doubles, but yet the bromate stays the same. The acid stays the same. So now we're only looking at the bromide. Everything else stays the same. So in this case, this doubles. And if you look at the rate between those two, you're going from 16 up to 32 times 10 to the negative third. So that also doubles. So therefore, that is a first order reaction again with respect to the bromide. And finally, let's take a look at the acid, the hydrogen ion. Well, in this case, we're going to have to compare reaction number 1 to reaction number 4, believe it or not. Because that's the only one in which, if these two double, notice that the bromide here and here stays the same, the bromate here and here stays the same, where the acid is doubling. So, if this multiplies by 2, what happens to the rate as you go from experiment 1 to experiment 4? It goes from 8 up to 32. So that's multiplying by 4. So it's quadrupling. So when the concentration doubles and the rate doubles, that is when the concentration doubles and the rate quadruples, that is a second order with respect to the hydrogen. All right? So we're running out of time here, so we'll go ahead and finish this up in the next podcast, and then we'll do yet another rate law problem. We'll see you in just a few.